Hi, everyone. Good morning. I'm John Cunningham, and I'm standing in Orlando in the Deep Space Lab. And today we're doing something very exciting, which I would consider a world's first. Uh, what we're going to be doing today is we're going to be showing how we can collaborate in virtual reality in physical spaces along with virtual spaces across 4 different or 5 different locations in the world. And what we're going to be doing is running through a number of different scenarios and showing different use cases using XR, using collaboration. And then we have something really special, which has not been done before, which we'll explain in a moment.
Yep. Hey, everyone. And to add on to what John just said, one of the unique aspects of this is the fact that we're running in VIROO rooms. We're using HTC Focus Visions. We have some Pico headsets. So there's a real variety of hardware. Right now, you see a bunch of people standing around, and we're inside a building. And this review that we're going to walk through is an early version of the VIROO BIM review template. What we did with this VIROO template, we brought the Revit scene in. You do not need a copy of Revit. All you need is a copy of Unity Industry that has the Unity Asset Manager and Pixie's functionality built in. The import script brings everything in. It cleans up any duplicates. It creates instances of duplicated geometry and optimizes the entire scene so that it's very performant. So what we can do with this is we can review building designs. And in this case, you can see one of the things that's been done. If you look at the screen, you can click on these doors as well as many other doors. They're interactive. The script that we created automatically makes these doors interactive. That was all driven through metadata on the doors. I should mention, when you import all this stuff, the hierarchy is fully preserved. The metadata is fully preserved. So a lot of this optimization, a lot of the work that's done can be strictly driven from metadata. You can move furniture around. So it's not just a static walkthrough of a building. It's being able to interact with that building. But let me show you a couple of cool tricks. So okay. I'm going to pull up a menu here. And what I did, I just hit the L key, but you could do this in VR, with a controller. And so we have layer visibility, so you can turn things on and off. There are categories defined in Revit, electrical or furniture or mechanical. I can, for example, turn off all the furniture and it disappears. I can turn off the doors, walls, and windows, and those will also disappear. So, the interactivity of this is just incredible. And I'd like everybody to follow me up to the 3rd floor. So we've set some teleport points here. And we have 4 teleport points set up. Those can also be set up automatically. So say, for example, you want certain points in a building that you want everybody to always be able to teleport to. You can create metadata, identifying those as teleport points, and then you can essentially just automatically create these teleports. The entire process from beginning to end, from importing the model to building it and opening up in VIROO, is minutes. And it's can be virtually entirely automated. So if you've got a standard schema for your BIM modeling and standard categories and such, and standard review points in a model, you can essentially just set up the import script, and it's all automatic.
We are now in a different use case. What we're doing here is we're going to be showing how you can use collaborative virtual reality in headset and on desktop to be able to do design reviews and user feedback testing of actual designs. So the situation here is that we are a restaurant operator, and we are testing some new kitchen designs to see which ones are the most effective. This is a very simple example, but it's designed to show the power of getting people together in a physical space and in virtual spaces to be able to collaborate on unique designs. So first thing we have a scene here, which is of just a normal commercial kitchen. And what I'd like to ask all the participants to do is just kind of walk around, go through the kitchen, familiarize yourself with it. And then what I'm going to ask you to do is to go over to the one side of the kitchen, because we're going to change scenes in a second. And you're going to see something different in the second kitchen than in the first kitchen. All right, now if you all could walk around this kitchen, and Kyle, since we're standing here together, can you see anything different about this kitchen?
It seems that there's a lot less clearance on the cooler side of the kitchen than there was previously. It feels a lot more open on this opposite side where I was standing earlier.
Can you open the door to the refrigerator?
No, there's definitely not enough clearance there with the current design.
So if you were working in this kitchen and you were a chef, would you be able to work in that space?
Oh, no, you're going to have a hard time keeping a chef in this kitchen.
Okay. What we did was we moved the center aisle of the kitchen closer to try to open up more side on one space of the kitchen. But what we ended up doing was removing space between the kitchen line and the refrigerator, which you can no longer walk through. So, Kyle, in your opinion, which of the kitchen designs would you recommend?
We'd say it's a difficult decision, but I'm going to go with the first one when you can actually open the cooler.
So we're now combining the power of training along with commercial kitchen design and engineering design review. Now let's move to use case 3. So now we're showing a different use case. We're showing an example of how you could use virtual reality in collaboration around different locations, different headsets, and something as simple as doing a design review of a new car design. And so if someone could go ahead and take the cover off the car, go ahead and interact with the doors. And what you can see now is we're getting a group of people from around the world to be able to go around and physically look at the design, talk about it, share notes, in a very high fidelity example of virtual reality. All right, now within the same application, we have a number of different scenes. We're now going to change to a healthcare example. So this application was developed for medical students, first-year medical students, to help them navigate and understand a typical hospital room. And there's some interactive examples here. This is a very simple design. It's not designed to teach clinical procedures. It's more of just an example of how you can use collaborative XR to, again, bring people in different locations into a virtual and physical space together. Okay, everyone, we're down to our last use case that we want to demonstrate today. And what we're doing here is something very unique. We're going to be demonstrating how you can run emulation of actual manufacturing lines. And when I use the word emulation, I mean emulation. We're actually running the real source code running on a manufacturer's PLC and virtualizing that information and then visualizing it in virtual reality. I'd like to introduce you today to Alberto Carlier. Take it away and explain to us what's going on.
As you said, we are able to connect in real time to automation systems. So engineers can plan and design, prototype, and test this automation system even before building prototypes. So what we are doing is connecting in real time to PLCs, robots, and all these systems. And we can even, with the integration with VIROO, test it in virtual reality. So we can test this before just building the prototypes, saving costs, saving risk. And this can be used to design, prototype, and even retrofit it. So you can just emulate, or you can be connected in real time to the factory to see changes in real time.
How big a factory line can you put in a cinematic instance?
We have infinite space here. It only depends on the power of your computer, but we talked about that before, that VIROO is a really efficient platform. So even running on low-end PCs are going to run just fine. And you can go as big as you want. Probably there's no factory big in the planet that doesn't fit inside Cinematic.
Alberto, that's fantastic. Thank you very much for that explanation. And I got a question for you. So you've been working in manufacturing and for your entire career. What are some of the benefits that manufacturers could get from taking this approach?
You know, the classic situation whenever you're developing new machinery, how does it all work together? Do all the controls work as expected? Do you get the cycle times that you're expecting? And there's always a phase, a commissioning phase, where you're frankly wringing out all of the bugs in the system. And a tool like Simumatic really helps you virtually commission equipment, so that you can work those problems out during the design phase. And once you actually have the physical equipment and you're ready to install it and get started, you're cutting time out of that process. You're cutting waste. But this can also be enabled in mixed reality, so that, for example, the equipment that you've got that you see here you can, if you're standing in an environment, say where it's going to be installed, you can enable mixed reality so you have pass through and you see only the equipment in virtual space, and then you see the real world in physical space. So that's also just one of the capabilities we don't show very often in VIROO, but I thought it was important to mention that this application is enabled for that.
That basically concludes the demonstrations that we were planning to do today. We could go on and on and on, but I think we've demonstrated today the power of this. And so, Ed, at the beginning of this, we said that we believe that this was going to be a world's first. And when we said world's first, we meant multi-user, multi-device, multi-location, multi-location-based tracking platforms running multiple different use cases, including digital twins training, architecture, engineering. Do you think that we've demonstrated that?
I think we demonstrated it. And I think importantly for customers, what we demonstrated is just the flexibility of, come as you are with the hardware you have. And in most cases, that's going to be what you need. So it's, I think absolutely this was a really solid demonstration of that.